Hello my friend, welcome to my channel. So today we are going to write the equation of the polynomial by looking at the nature of the zeros of the polynomial. Okay, so for example you have this graph. So this is a polynomial of degree 3. Okay, so we have to describe the zeros of this polynomial and then we have to write down the equation of the polynomial. So let's look at the zeros of this polynomial. As you can see, there's a 0 at x equals 1, right? And at x equals -2, you have another 0, right? So we have two zeros at x equals 1 and x equals -2, right? You have two zeros because the polynomial value at these 2 points is 0, right? So at x equals 1, look at the behavior of the graph. It is a straight line at x equals 1, right? So it's increasing, it's straight, right? So at this point, your polynomial has a simple 0. Simple 0 at x equals 1. But what about at x equals -2? As you can see, it is bounce, right? It's like bounce off the x-axis, right? So that means at x equals -2, you have a double 0. Multiplicity is 2 at this x equals -2, right? If you write down the complete factor form of this polynomial, you know an times x minus k1 times x minus k2 with powers, right? So let's see, we don't know yet about an, right? So let's write x minus 1 is one factor and it is a simple 0. The power is 1. And at x equals -2, the power is 2 because it is bounce. As you can see, the graph bounces off, right? So the power should be an even number and it is a double 0. So the power is 2, right? So this one is, so this is the factor form of this polynomial. We have to find this an. To find this an, you can substitute any coordinate over here. So I'm going to select this coordinate, the y-intercept. At x equals 0, y value is -4. If you substitute this one over here, let's see. So my p of x equals -4 at what? X equals 0. 0 minus 1 times to the power 1, right? 0 minus -2 times to the power 2. So I'm using this one to find this one, right? And here, what do you have? Here an times here -1 to the power 1, right? So -1 to the power 1 is -1. So here you have negative is positive 2 to the power 2, right? So then your an is what? So here an times here 2 times 2 is 4 times -4 here you have. And then an equals what? -4, you divide both sides by -4 gives you 1. An equals 1, right? Now you can write the whole polynomial. P of x equals, it's 1 times x minus 1 x. Now you can write this one plus 2 because negative is positive. So x plus 2 to the power 2. So this polynomial is this, right? If you want, you can expand this one and write down the standard form of the polynomial. Okay, so this is the complete factor form of this polynomial. Okay. Okay, let's see the next example. Here, as you can see, so let's find the zeros of this polynomial. So at x equals 3, we have a 0. At x equals 1, you have a 0, right? And also at x equals -1, you have a 0. Okay, so at x equals -1, you have a 0, and x equals 1, you have a 0, and x equals 3, you have a 0, right? So let's look at the nature of the zeros. As you can see, they are straight, right? Straight lines. So that means this one is a simple 0. This one also a simple 0. This one is also a simple 0, right? Okay. And now what can we do? Now we can write down the factor form of this polynomial an times x minus minus 1. We have a simple 0, the power is 1. And x equals 1, we have simple 0. And x equals 3, we have a simple 0. All the powers are 1, right? And how do you find an? So same thing, we can substitute any coordinate. Here I'm going to use the y-intercept. This value, y-intercept is 0, 3. So if you substitute, your p of x equals 3 at x equals 0. Okay, like this. So here an, you have an here. So simplify this one. 3 equals an times. Here you have negative, which is positive 1. Here you have negative 1. Here you have negative 3. So if you multiply this one, negative 3 times negative 1 is positive 1 times positive 3. Positive 3 times 1 is 3, right? So then your an is what? If you divide by 3 both sides, you get 1, right? So then you can write the complete factor form of this polynomial p of x. 1 times x minus minus is positive, so you can write x plus 1 to the power 1, x minus 1 to the power 1, x minus 3 to the power 1. So this is a degree 3 polynomial, right? The previous one also a degree 3 polynomial, right? X to the power 2, x to the power 1, total degree 3. Okay, so that's how you write down your polynomial by looking at the graph of the polynomial. Okay, first find the zeros and then find the multiplicity of the zeros, and then you can write down the complete factor form, and then you can find the an constant, and then you can write the complete polynomial function like this. So if you have any questions about this, please comment. Thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.